Hey guys, sorry about my voice. You guys already know I'm kind of sick, losing my voice, so bear with me. Today we're going to be talking about multiplying polynomials. Okay, so a polynomial is an algebraic expression that contains more than one term. If an algebraic expression contains only one term, they're called monomials. We have been working with monomials and polynomials since the beginning of school. So notice this first example, 3x, is a monomial, okay? It is one term. Negative 2x plus 5 is called a binomial because it's two terms. This next one, 5x squared minus 2x plus 4, is called a trinomial because it has 1, 2, 3 terms, okay? Notice these are classified as polynomials because they're more than one term. So let's review distribution, which you guys know is a form of multiplication. Okay, so number one here, I have x squared, which is outside the parentheses. So I'm going to circle that because that's what I'm distributing or multiplying to everything that's inside the parentheses. So x squared, or 1x squared, times 3x is, well, 1 times 3 is 3. How many x's do I have? Hopefully you're not saying 2, because remember, x squared means 2 x's, right? So there's actually 3 of them, so it's x to the third power. Now, x squared times 5, or 1x squared times 5. Well, 1 times 5 is positive 5, and there's only the x squared that's left over. These terms are not alike, and you can't combine them, so therefore that is the answer. Number 2, same concept. Circle what I'm distributing, what's outside the parentheses. And now let's multiply. 3x cubed times negative 2xy. Deal with your numbers. 3 times negative 2 is negative 6. How many x's do you have altogether? Remember, x cubed means you have 1, 2, 3 x's. So really there's 4 of them. So x to the 4th and 1y. Now let's continue to distribute. The 3x cubed times positive 3x squared y. Well, 3 times 3 gives us positive 9. How many x's do you have altogether? I have x cubed and x squared, so that's a total of 5 of them, so x to the 5th power, and I still only have 1y. Are these terms alike? No. This says x to the 4th y, and this one says x to the 5th y. They're not alike, so therefore that would be our answer. This should be a review right now. When multiplying binomials or trinomials, we also use distribution property. But because we are distributing more than one term, we must be sure to distribute each term. We basically call this double distribution. Notice here I've given you the example. Not sure if any of you guys are basketball fans, okay? This is Anthony Davis. He's known by his unibrow. Okay, kind of give you the same concept here if you look at my picture, right? There's his unibrow, right? Just kind of thought that'd be a little visual for some of you who are some basketball fans. But what we mean by double distribution is that we take the first term, okay, and we multiply it times the other first term. Then we take that first term and we multiply it by the last term. Then we go to the next term and we multiply it like so. And then finally here, okay? So that's kind of how the pattern works. Notice it's double distribution. All right, so let's go ahead and distribute number 1. 5x plus 2 times negative 3x minus 4. First thing that I'm going to distribute is the 5x. So 5x times negative 3x, well, 5 times negative 3 is negative 15. They have 2 x's in the problem, so that's x squared. Now, 5x times negative 4. Well, 5 times negative 4 is negative 20. And there's that x still. Now I got to distribute the positive 2. 2 times negative 3x is negative 6x. And then 2 times negative 4 is negative 8. Now you look to combine like terms. Typically, your 2 terms in the middle will be your terms that you can combine. So I would bring down the negative 15x squared. Negative 20x plus a negative 6x is negative 26x. And then I'd bring down the negative, or minus 8. And that would be our answer. All right, number 2, same exact concept. First thing I'm going to distribute is this x. So x times x gives us x squared. X times -3, -3x. All right, now I got to distribute the second term. So +3 times x, +3x. And finally, +3 times -3 is -9. I can combine like terms, which are typically the two terms in the middle. So I bring down the x squared. I'll bring down that -9. Let's see what we get when we combine like terms. What is -3x plus +3x? Well, hopefully you realize that actually gives you 0, so you don't really have to, they, in a sense, cancel each other out. So the answer is just x squared minus 9. This is a special situation because if you notice, right, they're both the same. The only difference is that one is positive and one is negative. So if you have exactly the same terms out here, x3, right, x3, but one's positive and one's negative, your answer, the middle term, is always going to end up canceling out. First thing you need to notice is, or ask yourself is, do we need to rewrite this? And the answer is yes. Remember anytime that we saw, for example, 3x squared, what that would mean? Yeah, that would tell us that we were multiplying the inside 2 times because that's the exponent on the outside, and we would rewrite it, 3x times 3x. That's the exact same concept right here. Okay, so notice I have a little 2 exponent on the outside. So what's on the inside of the parentheses I have to write down twice. 2x plus 3 times 2x plus 3. Now these look like the previous two problems we just did. 2x times 2x is, well, 2 times 2 is 4. Have an x and an x, so that's x squared. 2x times 3 is, 2 times 3 is positive 6. There's the 1x. Now the next term, positive 3 times 2x is positive 6x. And finally, 3 times positive 3, positive 9. Look to see, usually our middle terms are the ones that can combine because they're the ones that are alike. So I bring down the 4x squared. I'd bring down the positive 9. 6x plus 6x gives us positive 12x. You can't combine anything else, so that would be our answer. Number 4, I'm going to let you try on your own, but let's at least rewrite it. Notice you have a little exponent, 2, on the outside of the parentheses. So what's inside the parentheses, you have to write it twice. Negative 3x minus 5 times negative 3x minus 5. So go ahead and pause the video and try this out and see if you can end up with the correct answer. Alright, same exact concept still. First thing I'm distributing is the x squared. X squared times x. Remember, you got to be careful and ask yourself how many x's are there altogether. Okay, anytime you have a letter with an exponent, okay, whatever that exponent number is, that's how many of that letter you have. So if I have x squared, I know that really means I have 2 x's there. So x squared times x is x cubed. X squared times negative 5, that's negative 5x squared. Alright, now I got to distribute the next thing, which is the positive 3x. Positive 3x times x. Well, that's positive 3. There's 2 x's, so that's x squared. And finally, positive 3x times negative 5. Well, 3 times negative 5 is negative 15, and I still have that 1x. Notice again, the two terms that are in the middle, the negative 5x squared and the positive 3x squared, we can combine. The x cubed stays all by itself there. The negative 15x also stays by itself there, can't combine with anything. So let's combine the two in the middle. Negative 5x squared plus positive 3x squared gives us negative 2x squared. And that would be our answer. Notice our exponents are always in order from the biggest to the smallest. Number 6, go ahead and try that on your own. Okay, it's pretty straightforward. Double distribution. If you have to, whenever you have a letter that has no number in front of it, remember you can always write the number 1 in front of it to kind of help you in that instance. Okay? Multiply the polynomials. Sometimes we even have to distribute more than twice. So it's not always just going to be double distribution, okay? Sometimes it'll be more than one time. So if you notice here, I see that I got to distribute quite a few times. So let's distribute just the 2x. And I can tell, if you look at the second set of parentheses, how many times I have to distribute the 2x. I'd have to distribute it 1, 2, 3 times. And then I would do the same thing with the 3. 1, 2, 3 times. So let's go ahead and distribute. 2x times 3x squared. Well, 2 times 3 gives us 6. X and an x squared is x to the third power. All right? Again, 2x times positive 2x. Well, 2 times 2 is positive 4. I have an x and an x, so that's x squared. Distribute one more time. 2x times negative 5. Well, 2 times negative 5 is negative 10, and there's only that 1x, so there we go. So there's the first part. Now let's look at the second part. Distributing the positive 3. 3 times 3x squared is, well, 3 times 3 is 9. How many x's are there? Just x squared. 3 times 2x now. Well, 3 times 2 is positive 6. How many x's are there? Just the 1x. Then finally, 3 times negative 5 gives us negative 15. Now, let's see if we can combine anything. Can anything combine with the x cubed? Do you have anything else that has x cubed? No. What about the x squares? Any other x squares? Yep, 9x squared. Okay, what about the negative 10x? Does that combine with anything? Yep, with the positive 6x. And finally, does anything combine with the negative 15? No. Notice again how all the terms in the middle can combine, right? And the 2 on the outside don't. So I bring down the 6x cubed because I didn't combine that. And let's combine. 4x squared plus 9x squared is positive 13x squared. Negative 10x plus 6x would give us negative 4x. And then, of course, I'd make sure I bring down the minus 15. So that whole thing would be our answer. Okay, notice this is really just a lot of multiplication. I had to erase everything so that I had space to do this next problem. Okay, same idea. Okay, so let's circle the 2x squared because that's the first thing I'm distributing. 2x squared times 5x squared. Deal with the numbers. 2 times 5 is 10. Now, how many x's do you have together? Remember, we talked about this. X squared means you got 2 x's. So there's 2 x's and 2 x's, so that makes them 4. 2x squared times negative 3x. Well, 2 times negative 3 is negative 6. X squared and an x makes it 3 x's, so that's x to the third power. And finally, 2x squared times 2. Well, 2 times 2 is positive 4. And I have just those 2x squares. Now, I'm going to pause this and rewrite it a little bit over to the side. So that way I have a lot more space because I still got to distribute a lot more. Alright, so now let's distribute the negative 4x. Negative 4x times 5x squared is, well, negative 4 times 5 is negative 20. X and x squared gives me x to the third power. Negative 4x times negative 3x. Well, negative 4 times negative 3 is positive 12. I have an x and an x, so that's x squared. And finally, one more time, negative 4x times positive 2 is negative 8. And there's only just the 1x. Notice I'm actually not done distributing, am I? Nope, because I have this positive 5 that I also have to distribute. So 5 times 5x squared is positive 25x squared. 5 times negative 3x. 5 times negative 3 is negative 15, and then just the 1x. And finally, 5 times 2 is positive 10. I know this seems like a lot of work, but it really wasn't hard to do. It's just basic multiplication. Now let's see if we can combine like terms. Does anything combine with the 10x to the 4th power? Any other x to the 4th? Nope. All right, now let's look at negative 6x cubed. Anything else look like that? The negative 20x cubed. And that's it, okay? Now let's look at the 4x squared. Anything else with x squared? Yes, that has an x squared. Oh, and that has an x squared. And finally, what about the negative 8x? That will go, the negative 15x. Would anything go with the 10? No. All right, so notice again, right? What a coincidence. Everything in the inside here can combine with something, but the ones on the outsides come straight down because they don't combine with anything. So we get 10x to the 4th, and let's combine our like terms. So negative 6x cubed minus, or plus, negative 20x cubed would give us negative 26x cubed. All right, now the next one. The 4x squared plus 12x squared, well, that's 16x squared. And 16x squared plus the 25x squared would give us positive 41x squared. And then, what is the last thing we need to combine? The negative 8x with the negative 15x. And that would give us negative 23x. And don't you dare forget about it, that plus 10. Notice our answer, we can't combine anything else. And it's in order. The exponents are in order from the biggest exponent to the smallest exponent. All right, now we're going to look at some algebra tiles, okay? And we're going to actually write out what we see first. So notice this top one represents the first set of parentheses, okay? So you can imagine that this is the first problem inside parentheses. And what would I have? X plus 2. Okay, that's the top part. And then the bottom part, coincidentally, is also x plus 2. Okay? Now, we're actually going to kind of draw this out and see what we get. So notice the x times x gives us x squared, right? 1 times x gives us 1x. 1 times x gives us 1x. Remember, guys, this multiplication dot right here means to multiply. That's why I'm multiplying. All right? X times 1 gives us 1x. And then x times 1 gives us 1x. 1 times 1 gives us 1. 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 Notice by drawing this picture, we actually can already see what our answer is, right? I see that my answer is going to be x squared, because I only got one of them, right? 1x squared. How many x's do I see? 1, 2, 3, 4. So plus 4x. And then how many ones do I have? 1, 2, 3, 4. Plus 4. So that would be the answer using algebra tiles. Alright, so let's look at the next one. Same exact concept, okay? So I'm going to draw this out. X times x would be x squared. X times x would again be x squared. Negative 1 times x would actually make this a negative x. Negative 1 times x again would make this a negative x. X times negative 1 would give us a negative x. X times negative 1 would give us a negative x. Negative 1 times negative 1 would turn into a positive 1. And negative 1 times negative 1 also would turn into a positive 1. Notice I forgot to write out our factors, which we had 2x minus 2 on the top. And here on the side we have x minus 1. So let's see what our answer is. How many of each do we have? How many x squares do you have? There's 2, so that would be 2x squared. Notice we have all negative x's here, right? Negative x, negative x, negative x, negative x. So they're all the same, so that'd be negative 4x. And then I have 2 positive ones, so that's plus 2. That would be the answer. Alright, so let's do number 1 together. We're finding each product. Product, remember, still means multiplication, so we're multiplying. Notice we actually have to draw the tiles on the outside first to figure out what they give us on the inside so we get our final answer. Alright, so I have 2x, so there's an x, there's an x, and then 3 negative 1 boxes. Alright, and then x plus 1, well, that's just 1x, and then a positive 1. Probably should have color-coded this a little bit better. Alright, so now let's multiply. X times x gives us x squared. X times x gives us x squared. Okay, negative 1 times x gives us a negative x. Negative 1 times x also again gives us a negative x. And negative 1 times x one more time still gives us a negative x. Right? Not done multiplying, almost done. X times 1 is positive x. X times 1 is positive x. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. And negative 1 times 1 is negative 1. So let's see what our answer is. How many x squares do we have? 2, so that's 2x squared. Now, here we have to be careful, because if you notice, alright, we have negative x's and positive x's. So they're going to actually end up canceling each other out. So if I have a negative x, that's going to cancel itself out with a positive x. If I have a negative x, it's going to cancel out with a positive x. So how many x's do I really have left? Just 1, and it's a negative x. And finally, I have negative 1, 2, 3. So that would be the answer for this problem. I want you to try this one on your own, but let me at least help you with one part. Remember what we talked about. X went on the outside of the parentheses, so that means that problem's written twice. It's x minus 2 times x minus 2. Alright, so let me just draw it out for you or with you. Okay, so I have a positive x, and then negative 1, negative 1. Same thing here, right? I have a positive x, negative 1, negative 1. So go ahead and multiply it and see what you get, and then write your answer. If the length of a rectangle is 2x plus 4 and the width is x minus 4, then what equation will represent the area? Well, the first thing you need to ask yourself is, what is the area of a rectangle? Well, hopefully you know that it's length times width. So basically they're telling us that we need to take this length, which is 2x plus 4, and we're going to multiply it times x minus 4. Okay, notice this is a setup just like all our previous problems, okay? So let's just go ahead and do double distribution. 2x times x. Well, 2 times 1 is 2. I have an x and an x, so that's x squared. 2x times negative 4. Well, 2 times negative 4 is negative 8. I have 1x, so I make sure I keep it. Now, positive 4. 4 times x, or 1x, 4 times 1 is positive 4, and I got the 1x. I got to bring down the x. And finally, 4 times negative 4 is negative 16. Remember, I look to combine my like terms, and they're, notice, right there in the middle. So, I bring down the 2x squared. Negative 8x plus 4x is going to add up to negative 4x. And I make sure I bring down the negative 16. So this would be the area of the rectangle. Number 12. If the length of a rectangle is 4x plus 2, and the area of the rectangle is 8x squared plus 2x minus 10, then what binomial represents the width? Okay, so we know that one of the sides, right, the length is 4x plus 2. We don't know what the other side is, but we do know that it's supposed to equal 8x squared plus 2x minus 10. So we're trying to figure out what is this missing binomial. A few different ways that you can do this. We can actually just, we can do guess and check and see if it works. You can try the algebra tiles and see if that works for you. So I want to see if you can come up with what this answer is going to be. Okay, so you can either guess and check, right? Just try different numbers. Like, for example, I know that the beginning probably has to be a 2x, right? Because 2x times 4x is going to give me 8x squared. Okay, but what would be the ending part? Would it be plus 10, plus what? Or would it be a minus something? Okay, so that's what you have to figure out. Would it be plus or minus, and what number? Alright, so you can do guess and check, or you can set up your algebra tiles, and you know that one of the outsides, right, has 1, 2, 3, 4, right? 4 x's, and then 1, 2. And then you know the inside has what? 8x squared, so that's 8 of these big rectangles that you have to have, or big squares, right? So those are all 8x squares. Which kind of gives away the fact that this has to be a positive x, and that this has to be a positive x, like we just said, right? It's got to be 2x out here. So you got to figure out the rest of it. Okay, so have fun with that. We'll obviously go over this one in class. Till next time.